All right. Hey, Peter. Hey, Tarun. And hey, everybody else. Thank you for coming. So first, I kind of want to go over how I'm going to do this presentation. It's going to be pretty straightforward, but I'm going to show you kind of what we're doing at Comcast when it comes to Splunk. This is a real deep dive. Like, you guys know what Splunk is, you know what it does. Like, you're going to actually see how we kind of like operate Splunk and kind of some of the challenges that we've gone through. I'm going to kind of try to steer away from like the cool metrics that we have, but you'll see them pop up. But a couple of things. This is who I am. I work at Comcast, obviously, and I worked in government before that, and I worked for a power grid operator before that. I've kind of done Splunk there the entire, every place that I've been. NOAA, we use it for scientists and trying to track down license issues with the software that they were using. At the power grid operator, we were looking at how systems that help transmit electricity across the grid, they kind of tag every piece of energy. So we were looking at ways of like understanding that in like a Christmas tree format. Yellow, it's not doing well. Red, it's bad. Check it up because energy matters. I also play semi-pro baseball. Last time I was out in the West in Arizona, I got to play at the Arizona Diamondbacks training facility, which was pretty cool. The fields are huge. I'm a supernumerary in Opera. I do a lot of open source work and code for Philly, and I'm your friendly neighborhood Splunker. So we're going to do this we're going to run through some stuff here. We're going to talk about all the data that we have. I'm going to show you how we get these 750 indexers kind of like doing the thing. I'm going to show you how the 12-node search head cluster works across multiple AWS regions. And I want to tell you a little bit about we use less indexes, more source types. We kind of do indexes based on where the data is coming from. So we kind of like have our products are in certain indexes. We don't have like lots of indexes for everything. Kind of keeps everything easily managed. So I'm going to do this like an opera. We're going to start at the prologue. So me and my team actually, my director's here, Peter, and then my colleague Tarun, and we kind of like we work in technology and product experience inside of Comcast. There's 20 plus million subscribers, set-top boxes for people to view the Xfinity TV experience, which is supported by the cross-runtime environment and the reference design kit. Essentially, we have a very unique platform. If you've ever watched TV and you have had a cable box, you probably used like a guide or you tuned to some channels. And basically tuning to those channels in the guide, we kind of like have that digitized inside of a cloud infrastructure, which is called the cross-runtime environment. Outside of that, on top of the set-top box, we can kind of like deploy different looks and feels about how the applications work. Particularly the reference design kit is easily tweakable that way. So if you want to record something in the cloud, you don't need to have the equipment on-prem. You just need to have our set-top box, and we take care of all the coordination and scheduling of your DVR recording on our system. There's some other things in there. The guide is in there. The voice remote technology, if you have that, when you speak into that, a lot of the folks are looking at trying to figure out whether what you asked for is actually what showed up. And we also have like our Xfinity Home product inside there. There are also support services in there. Those are back-end infrastructure, back-end systems such as like your Wi-Fi access points, your high-speed delivery, and like there's various IT-related things in there. But the one thing that makes our Splunk kind of unique from others is that we don't do too much IT work inside of it. Most of the stuff is relative to the applications that developers are developing. So this is like a quick view into our monitoring console. We have hosts that go in and out all the time. We learn and scale at the same time. We learn a lesson, we scale. We try to get into a better position every single time we actually have a problem. The DMC is one of the things that we look at, but if you're really looking into kind of like what we have here, we're actually about to we're in the process of deploying an additional 112 indexers. And we always have indexers offline, but just to give you a snapshot, we're looking at about 1.2 gigabytes a second of data that we're bringing in. And we have to make sure we get that data in. We have to make sure that the customers can search it. And our customers actually are like the Splunk users, and we have about 3,000 plus individual Splunk users. So how do we learn and scale? That's kind of like a very interesting question. Like, because a lot of folks think we have like super beefy hardware that's more for like has high compute power. We actually focus on all the hardware for ingest. We got to get the data in. So we have hardware that is basically IOPS intensive. It brings in data up to 250 gigabytes a day. Like, everything surrounds getting the data in and then allowing the search to happen on the indexers themselves. Again, we try to buy for growth. We try to understand that we're onboarding new data. And I can't stress it enough. Automation, more automation. As soon as you figure out that you're clicking or turning a crank, you got to automate it, because at a scale that, across the United States, like how we have it, you're going to have a really hard time trying to keep turning that crank repeatedly. I want to touch on this one real quick. Locality matters. So our data centers are spread across the United States, and we have them in very unique places for a reason. We have them close to the forwarders. So if we have forwarders that are in a specific region, the indexers are there. So if it's in the east, they're in the east. If it's in the central, it's in the central. And if it's in the west, it's in the west. We don't really support the forwarders. There's 50,000 of them. So we try to support the process through enabling people to self-service and manage the forwarders on their own. We welcome new data, but how do we handle all that? And I want to touch on that real quick with something that's called Imposter. This is an internal thing that we have that allows us to kind of on the fly designate new source types that potentially will look like other source types that we've had in the past. This allows us to not have to restart all those indexers all the time. So basically, we have folks come in here and look for the particular source type, or like a regular expression that matches their data, and then they pick that source type and then they attach it to their monitoring stanza. This is an easy way for us to do this, and it kind of enables this self-service type of infrastructure that we're trying to get with the forwarders. This app is deployed to all the indexers, and again, allows us to match the specific without needing to restart the indexers. So what's under the hood of an indexer? This one's a little bit compute low, but it's ingest heavy. Today is like during the time that I took the snapshot, the activity is kind of low. Some of these will peak around 80 to 90% utilization. So that 1.2 gigabyte number that per second, I've seen it up to 2.2. So like almost doubled the amount of intake that we're getting per second. Those are snapshots. That's not sustained over time. That's just a look. Our average is probably like 1.5. We have your typical setup for opt, where Splunk lives in a hot and a cold bucket. Everything's direct attached storage. We try to stay away from NFS. So these machines are big. They take up a lot of data center space. But for the majority, they're always online and they always have their disk available. So the main concern is right around the IOPS, making sure that we have multiple channels. If you've ever deployed like very large direct attached storage, sometimes your I/O channels are actually 1 and 2. We actually have 16. So we have that amount of throughput for ingest. Again, it's all about getting the data in. And as we kind of approach that number, that metric gigabyte per second, we're about 140 terabyte a day. So where is it? We do distributed search at national data centers. We do them at regional data centers. And we kind of do it in AWS, and I'll explain that in a moment. So we have major data centers across the United States, and we have indexers there. Our entire search cluster is connected to each one of those data centers with the indexers. along with the regional data centers. There's like 34, 35 plus. And then we kind of pull ingest in from AWS, but we bring it back to Comcast and do the indexing there. So there's not the kind of locality that you would think geographically, like how we do with the national data centers and the regional data centers, but we kind of try to like keep that vibe going. So what types of data do you have? So we've got unstructured, structured, Lambda, Kinesis, and very interestingly, someone put the entire TV guide in there. So, I mean, I guess if you want to figure out what's on TV via Splunk, you could do that. So that's pretty cool. There's not too much interactivity with demos just because there's proprietary information in our Splunk install. So I tried to screenshot the things that you as Splunkers would probably get the most value from, rather than sitting here SPLing through our system, which can be a little bit sensitive. So we have real-time monitoring for both our Splunk. So we do Splunk on Splunk. We also have other monitoring tools that we do it. But for the most part, those 3,000 unique individuals, they're probably looking at customer experience dashboards, ingest automation, which I'll explain to you later, and then an end-to-end view of the customer experience on the X1 platform. What does that mean? I turned on the TV. I tried to watch baseball. It didn't work. What the heck happened? Why did I get billed for it? We can see what happened, kind of like help get that question answered a lot better. So I have one demo screen that I want to show you, but I just put this disclaimer up here real quick. This is just kind of like what you can do if you're like an ISP or like a cable company. You're trying to figure out what the customer experience is. This is something we did a long time ago, where we were trying to figure out over the last 30 days what happened with the customer. And you probably have had this experience before. Something happened, you called, and then we had to visit you. So we kind of built this like little scale that takes from what is like an incident voice recording, which is basically someone calling into our call center, trying to figure out what issue they were having, how many times they called in a 30-day window, and if we ever visited them, and maybe if there's any errors, related to gear that they had in the house. Did a little bit of scoring and kind of, once you get that summary of the scoring, you as your company would be like, hey, these customers are having like a bad time, so we could like check that out. Okay, so before we move on to Act 1, questions. I'm going to do questions in between the acts so that you guys can like just like go back and forth if you have anything. Questions? No? Okay. All right. So indexer and search at cluster architecture, distributed search on a national scale. How do we do it? So we have a 12-node search at cluster with distributed search. We have a Splunk deployment server cluster. We also have monitoring via OP5 and Zabbix. And that basically means that we have monitoring. That monitoring kind of comes in when automation doesn't handle a server's problem. So sometimes we have issues that actually we need to step in and kind of fix. So this multi-region search head cluster actually exists in AWS. So we intend to go 3 regions. We're waiting for a direct connect in one of the regions. But right now we have US East 1 and US West 2. And essentially the search head cluster, this is a status that you would see, is all managed by AWS automation. This includes like the build of the server. This also includes the monitoring and making sure the server is running. And we also check to make sure that Splunk is running on the server. So this unhealthy status you see here is basically it removing it from the load balancer and saying like, hey, Splunk is restarting. Don't worry about it right now. It doesn't need to be rebuilt or anything like that. It's actually stable. So we have 3 regions. We have 4 search head nodes in US East 1, and we have 8 in US West 2. They're lopsided like that for a reason. There's Buttercup. This is what the routing policy looks like on the back end. So if you have a multi-region cluster, you have to consider the high availability at all components. That includes the URL that you're using. That includes the routing policy that you're using in DNS. That includes the region, availability zone, and the machines themselves. And we kind of did that throughout the entire install inside of AWS, allowing for someone to hit one URL and have them route it to where there's available Splunk search heads. The difficulty with that is we tried it geographically, and we're still kind of working with this. Some users hop on the VPN and their locality changes quickly, and then one side gets overwhelmed and one side, has a problem. So what we have inside of AWS is a load balancer that can handle that type of like round robin. This is where you need to be. This is where you should be. This is the ultimate kind of like you're going to get connectivity. And we had to do a lot of tuning to get it to work. And we recently did kind of like a test to see what would happen when a particular region was down, and we were able to maintain search as architected. So let's talk about this. This is actually in AWS's documentation on how you would do a multi-region Splunk architecture. This basically just describes the different public subnets that you would use. We have essentially one indexer in each availability zone. And then we don't do index or cluster, but this is kind of an example of like how you would do this type of install on AWS. Ours is very specific use case, and to be honest, like it's really hard to share our architecture if you're not an ISP, because we have connectivity with low latency to most if not all cloud providers. So we're able to do things that are probably not going to fit well with maybe if you're a smaller company. This is essentially what it looks like. We basically have DX VPCs that come out of each of the regions. We're still waiting on this region. This gives us enough to actually do that low latency communication for bundle replication with the indexers in wherever they're local at Comcast. So let's look at that workflow real quick. So users use one URL for the UI, one for the API that connects to the search head cluster. It does all the stuff that I just described. It hits AWS. AWS decides where it needs to route, whether it's going to be on the west side or on the east side, and then it delivers the Splunk UI to that person trying to access. Our private DX VPCs, this is just fancy term for virtual private clouds that are connected directly to your company with basically either area routers or core routers. And that allows the connectivity between the indexers and the search heads. And then data that needs to use cross-region connectivity will use a Comcast backbone to travel. And we're in sub-second latency right now, which is actually pretty good. We saw it kind of creep up for a little bit, but then it started to go down as we made improvements. So that essentially means that a search head that's in possibly like Virginia can communicate with a search head that's possibly in Washington under 78 milliseconds to do bundle replication. But does it work? It does. We kind of like went through a couple of things relative to timeouts and connectivity. We had to actually adjust the presentation later timeout so that they would be shorter. What we were finding is people were keeping sessions open for a long time, and continuing to keep those sessions open actually ties up Splunk while other people are trying to use it. This is, wait for one moment. Yeah, I don't know. So shorter timeouts also means less abuse from CRUL. So if you can imagine, with the amount of people that are connecting to our Splunk, we kind of have people that are abusing it in ways that, would happen. So we had folks running queries for over 30 minutes, sometimes up to an hour, sometimes up to 6 hours, sometimes up to 12 hours. What we found out is that they were issuing curl commands and keeping sessions open for that entire time. So we removed we made the session timeouts really short. They complained. We said use the software development kit that allows you to make that quick connection, ask Splunk to run your job, wait for the job to finish, fetch it. It is taking down, we used to have search heads restart pretty much every 2 to 4 hours. and now they're like once every 7 days, I guess, or in between there. So like that was a significant improvement. Splunk, though, on the other hand, the Splunk D process actually needs additional timeout time since it has to traverse basically across the United States. When we had shorter timeouts, we saw that bundle replication stopped, bundle replication would not occur. So we had to fix that by essentially making the Splunk D timeouts longer. Snapshots and bundles, we had to reduce the size of those. 8.7 gigabytes going across the network seems like trivial when it's a 100 gig connection, but it gets really hard for like one machine to do that every 5 seconds. So these are the problems. I'm going to do the quick, and then we'll do the dirty. Long-running searches keep connections open too long. We tune them to be shorter, but use search policy to help. This is what we ended up with. These are the timeout settings that allowed us to basically do this multi-region search egg cluster. We started with the replication threads. We changed the connection timeouts from what their default settings are around the minute. We bumped them up to 2 minutes. It's very simple what we changed, but it was very significant in keeping the cluster up and running at all the time. We also, we've always done this, but users will sometimes be like, I need to look at all the set-top boxes in a particular region. So they'll go ahead and upload like a 6 gigabyte CSV file. Yeah, that basically brings search almost to a halt. So we blacklist them from actually doing that. So if you upload a CSV file to a search head and you bring it down, it's your own fault. It doesn't affect the cluster. So what are some of the lessons learned from rolling out this kind of like architecture? One of the things we notice is that when we span the entire United States, networking does changes. Like, you're probably used to the changes that occur in the data center. We are now affected by changes that occur across the internet. So sometimes they just don't notify you and your search goes down because, hey, there's a link down on the internet. I mean, most people are not going to run into this issue, but we happen to do that as an ISP because we provide the backbone. Users are going to find problems faster than you. Just own up to it. Like, I can't tell you how many times in the Slack channel someone is like, Splunk is slow, and you're like, all right, do I do something? Do I investigate? Will it heal on its own? You kind of just let them kind of be like the monitoring for the user experience, and then you kind of figure out if there's any cranks you do not need to turn. Go ahead and automate it. And again, don't be a hero. Be part of the community and focus on those hot spots. Because a lot of times some of these customers will signal things that we can't see through our monitoring. And once we go and fix it, we actually fix a lot more than just their problem. We fix problems we have. We fix problems that that other folks using our platform are having. All right. So that was a lot. It's a long talk. Questions? Yeah. So Peter asked, how often is our bundle replication rate? So we usually do it very quickly, but sometimes we actually push it out. So we actually have it set now to every 30 seconds. We actually had it at 5 seconds. So now that we've moved it out a little bit longer, that allows the bundle replication to actually occur and actually happen. All right. Act 2. Here's the fun stuff. All right. Automation. I'm a really lazy engineer. The computer has all the compute power. I want to be able to let the computer do what it needs to do. I mean, we spend tons of money on this stuff. Let's make it do stuff. Self-service ingestion, bots, role-based access control and power users, and community-first goals. We have over 3,000 unique users, so we need to be sure that Splunk has their data. That's where we need to focus the most of our time. A lot of folks will come in and say, oh my God, search is down. I'm like, oh my God, is the data there? Because that's where search actually occurs on the indexers. So having the search head availability, yes, is important, but we really need to make sure that the data is there, because if it's not, then what's the point? So I'm going to go over what basically we use for deploying out to these 50,000 forwarders. So we have a homegrown solution that basically uses Git and Bamboo to essentially allow anybody that's going to check in a monitoring stanza or like an app or anything to check it in, and all the syntax checking that goes along with that, the location and the deployment to the indexers that it's, or excuse me, the forwarders that it's supposed to go to, is handled basically by our continuous integration and platform. This is built specifically for us. So what basically you get from this is you get your build successful, and you can actually go back and look at essentially what was done to allow for this to happen. So we basically, anytime someone checks in code, we tell GitHub Enterprise that someone's checking in code and put the particular commit in a pending status. We then check out whatever they did onto onto the continuous integration platform, and we run Splunk on that. We actually run like an actual Splunk install on there. We make a staging directory, and we copy all the Splunk configs that would go out to a deployment server onto that machine. We create a symbolic link for the deployment apps, because there's a bug with Splunk where it can't see deployment apps inside that are not inside of the Opta directory, even if you tell it to look there. So we do that by just creating a symbolic link, which is all done in like the scripting and automation. We then use btoolcheck to check the source files, and then if they look good, we tell GitHub, hey, good to go. What happens here is essentially we check to make sure that anybody that's writing any monitoring configuration stanzas actually wrote it correctly. So if you have a typo or you're not using the monitoring stanza correctly, it bombs out and basically stops the commit from ever getting to the release branch. We then do a quick check to make sure that the source files are changed that would affect the Splunk binary from starting. Because every time we essentially roll this out, the Splunk deployment server actually reloads. And then this is a cleanup command, which basically just cleans things up. There's a couple of other things that you should kind of like think about when you're doing automation. You should think about the fact that when you're doing automation, the computer's doing the work, and there's a chance that a human comes along and does something. So inside some of these tasks are basically delete anything that a human did, because I'm going to do all the work. It's just like an automation kind of like pro tip, if you will. Once that's all done and the PR has been approved, the deployment service comes along, picks up all the configs, takes it out to our 12-node deployment server cluster, drops them all in, writes all the directories, reloads Splunk, all 50,000 forwarders, phone home on an average interval about 30 minutes. So all those configs roll out. So your data that you are trying to ingest could show up within 1 to 30 minutes of you getting your PR approved. And we don't do any work at all. We just click, looks good, syntax checking is already done, approved. And this is what it looks like. You have someone in the Comcast community basically submitting a commit. You see the merge pull requests come in from him from his sort repo. You see the review done by somebody on one of our teams. And then you see the approved changes. It passes all the configuration checks and basically gets deployed. So you do it, you own it. You don't have to come to us to ingest data unless it's a special use case. Errors can be easily tracked because it literally says this is an error. And it's a 12-node deployment server that can handle the nodes. It can handle all those 50,000 forwarders. So we have bots actually at one point in time deployed to our system. We actually don't have this deployed now, but one of the things is we would have folks come in and they'd be like, hey, I need access to the system. They would ask, we have this bot that would say yes. and the person would respond yes, and then they would say, this is how you get access to the system. We took that a little bit further, and we integrated into the deployment system here, and it basically allows anybody that's deploying anything for Splunk to go out and grab the ticket that's relative to what's being deployed. So one of the things that's really important if you're trying to get your users to do their own role, or like power users, being able to set up role-based access control. So every role in Splunk has an AD group. There are even groups for a function like login, and I'll explain to you why that's like important, because it allows you to do some really interesting things when you have like a huge Splunk install that maybe you need people not to search on. And apps have roles too, to continue the hierarchy. So we have a role for login. The user group is part of that login role, and the admin is part of the user role. Because inside of Splunk, you can actually designate people to log. You can actually have a role for just logging into Splunk. Thank you. Excuse me. Perfect. Thank you. So essentially, no one's in the login role. Why? Because if we want to stop folks from logging in, if we try to actually disable their accounts or do whatever, it would be virtually impossible. So all we do is just disable the login group, and then nobody can log into Splunk, and we can do maintenance. Admins are part of the user group, because admins essentially do most of the user functions, which is search, but we also have some additional functions. One of the things that we try to do with our community is try to publish the root cause analysis quickly. We try to help users graduate into better searches. We do have users that are like, I need to look at the MAC address of a set-top box. Copy, paste, search. 7 days. 140 terabytes a day. That's 5 petabytes that they're trying to search for a MAC address. Not happening. We're going to put in guardrails. Right now, we allow searches to run for about 12 hours. We're looking to go to 6, 2, and eventually 30 minutes. The reason why we want to do that is we want to get folks more concentrated searches, and if they need to do batching, we'll show them how to do load jobs and let the system do the number crunching. On average, we have about like 45 concurrent searches, but we do have some systems that use Splunk that end up putting out about 550,000 individual searches a day. And we're working on getting office hours, which is basically kind of like this, where folks come as a community at our workplace and just kind of like interface with us instead of like, I have a problem, maybe they want to learn something new or they want to get interactive type of help. So that's the end of that. If you have any questions, this is like where I can kind of like continue to deep dive. I can answer what you would like to know about doing distributed search across the US and kind of like how we use automation to kind of like accomplish this heavy feat between 5 of us. So